Right now, roughly 150,000 people around the world will die today. Their hearts will stop. Doctors will call time of death, and everyone in the room will assume the story is over. Except it isn't. In 2022, a team of neuroscientists in Vancouver accidentally recorded something that should have been impossible. An 87-year-old man came into the hospital after a fall. He'd developed epilepsy, so doctors attached an EEG cap to his scalp to monitor seizures. Standard procedure. Then, during the recording, his heart stopped. He died. But the EEG kept running, and what it captured in the next 30 seconds left the research team silent. The man's brain exploded with activity. Gamma waves surged across the cortex. These aren't random electrical spasms. Gamma oscillations are the brain waves your brain produces when you concentrate, retrieve a memory, or dream. The dying man's brain was firing in patterns identical to someone actively remembering their life. Dr. Ajmal Zemmar, the neurosurgeon who organized the study, measured 900 seconds of brain activity around the moment of death. He focused on the 30 seconds before and after the heart stopped. In both windows, gamma waves spiked. Alpha, beta, theta, and delta waves fired in coordination. The brain wasn't shutting down. It was organizing something. Zemmar published the findings in Frontiers in Aging Neuroscience. The paper went global overnight. But this was more than a single case study. 9 years earlier, in 2013, neuroscientist Jimo Borjigian at the University of Michigan ran an experiment on 9 rats. She stopped their hearts and measured what happened inside their brains. All 9 showed the same result: a massive surge of gamma oscillations for roughly 30 seconds after clinical death. The activity levels were higher than anything recorded during normal waking life. Published in the Proceedings of the National Academy of Sciences, the study concluded that the mammalian brain can generate neural signatures of heightened conscious processing at clinical death. Heightened conscious processing. After the heart has already stopped. Then came 2023. Borjigian published a follow-up, this time on humans. Her team analyzed EEG recordings from 4 comatose patients who died after removal of ventilatory support. 2 of the 4 showed a rapid surge of gamma activity the moment oxygen stopped reaching their brains. The gamma waves connected across hemispheres, linking the temporoparieto-occipital junction to the prefrontal cortex. The exact regions involved in conscious perception, visual processing, and self-awareness. So here's the question nobody can answer yet. Were those patients experiencing something? We can't ask them. They're dead. But the brain activity matches what a conscious, remembering, perceiving mind looks like on an EEG. And there's a separate line of evidence. Nearly 20% of people who survive cardiac arrest report a near-death experience. Dr. Sam Parnia at NYU Langone studied 567 cardiac arrest patients across the US and UK. Of the survivors interviewed, 40% reported some form of awareness while their hearts weren't beating. They described separating from their bodies, reviewing entire lives in seconds, encountering deceased relatives. Parnia's team also detected spikes of brain activity up to an hour into CPR. 1 hour. After the heart had stopped. So what exactly is happening inside a dying brain? One theory points to chemistry. In 2019, Borjigian's lab found that rat brains synthesize DMT, the same psychedelic compound found in ayahuasca. The enzymes exist across the neocortex and hippocampus. When researchers induced cardiac arrest in rats, DMT levels in the visual cortex jumped to concentrations comparable to serotonin. DMT binds to the sigma-1 receptor, which protects cells from dying when oxygen drops, so the brain may flood itself with this molecule as a last chemical defense. But nobody has confirmed DMT reaches those levels in a dying human brain, only in rats. The second theory is electrical. In 2023, researchers at Paris Brain Institute tracked what they called the wave of death. When oxygen stops reaching the cortex, neurons burn through remaining energy in minutes. Then, a massive wave of depolarization begins in layer 5 of the neocortex and spreads outward, upward toward the surface, downward into the white matter, a few millimeters per minute. Before this wave arrives, the gamma surge fires first. Heart stops, oxygen drops, gamma waves explode. Then the wave of death sweeps through and shuts everything down. Between those two events, something is happening that neuroscience cannot fully explain. And the Paris team showed the wave of death can be reversed. If the brain is reoxygenated fast enough, neurons recover. Death in the brain is a process with a window, not a switch. Patients have been brought back after 20, 30, even 40 minutes of cardiac arrest. Some report vivid memories from that period. A woman described hearing her deceased grandmother telling her to go back. A man recalled watching doctors perform chest compressions on him from above. Two patients accurately described specific actions the staff performed while they were clinically dead, verified by the medical team. None of this proves an afterlife. Borjigin, Zemmar, and Parnia have all been careful to say that. What it proves is that your brain doesn't just go dark when your heart stops. For at least 30 seconds, it enters a state that looks, on every instrument we have, like heightened consciousness. Gamma waves across hemispheres, coordinated oscillations between regions for vision, memory, and self-awareness, possible floods of endogenous DMT. A cascade so organized that researchers keep using the same word: paradox. Borjigin has spent over a decade trying to answer this. Her lab is recruiting more ICU patients, building a dataset that might reveal whether this gamma surge maps onto actual experience. Because the biggest limitation is simple. The people whose brains produced these signals did not survive to tell us what they felt. Every civilization in human history has had stories about what happens after death. The Egyptians described a journey through the Duat. The Greeks spoke of crossing the river Styx. Tibetan monks wrote maps of the Bardo. For thousands of years, we called these myths. Neuroscience isn't saying they were right, but the dying brain does something so unusual that we cannot explain it with any current model of consciousness. 30 seconds. That's how long the gamma surge lasts after your heart stops. In that half minute, your brain is more electrically active than when you were reading this sentence, producing the exact oscillations associated with memory recall and dreaming. And then the wave of death arrives, and the lights go out for good. We don't know what those 30 seconds contain, but your brain has already rehearsed the script. It fires every night when you dream, every time you dig through an old memory, every moment you close your eyes and concentrate. The same gamma waves, the same patterns, practiced over and over across your whole lifetime, as if your brain has been preparing for those final 30 seconds all along.